And there we go. We're at the top of the hour. So I'd like to welcome you to the future of work. Today's topic, integrating emerging technologies. This is the third webinar in our series. And I'm sorry, the date there says April 22nd. It really is May 20th today. So excuse me for the small glitch right there. I'm your host, Mike Lisecki. And our presenter today for the majority of the presentation is Kristine Christensen. She's with Moraine Valley Community College. Kristine, let me welcome you to the audience. Why don't you just say hello to everybody? We'll check out your audio before we get started.
Hi, Mike. Thank you for this opportunity. I'm from Moraine Valley Community College. I teach in the Computer Information Systems Department, and I'm very happy to be here.
You sound perfect today, Kristine.
Oh, great. Thank you, Mike.
So now let's talk about briefly, folks, about the project goals, this future of work thing that we have. Well, number one, we want to empower community colleges, faculty at community colleges, promote regional collaboration, support ATE regional networks that are focused on this topic of the future of work. And importantly, number four, foster implementation of the cross-disciplinary STEM core. What's happening out there today? Well, all of us know what's happening in a way, right? The nature of work is changing at really unprecedented speeds. And you hear things in every news thing you read today about machine learning, AI, Internet of Things. That's our topic for today. Robotics, automations. You know, technicians sit at much of this disruption that's happening, and their jobs are changing too. And often us, the majority of us are educators, have to keep up and knowing that our students' career paths are changing as well. So I like this term, future-proofing STEM education. So to approach this, our project identified 3 skill areas: data knowledge, advanced data literacy, and business knowledge processes. So let's talk about this in a little more detail. We're not going to go through each line in this, but if you focus your eyes on the center, right? Advanced digital literacy, understanding the communication and networking and all the other aspects of it. Scan your eyes down and it says Internet of Things, and that's today's topic. To find out more about this, I put a link in there. Essentially, if you go to Preparing Technicians, all one word, .org, you can find this out, or you can go directly to that link. Now, before we get started, Kristine, today, and put you on the hot seat, let's start by asking our attendees this question. So here we go. Attendees, you now see this poll in front of you. If you were king or queen or whoever, where would you put IoT in the curriculum? Would it be in the business department, the computer science department, electronics, engineering, IT, computer information systems? Good, lots of results coming in. This is not a hard one. Come on, think of your answers, and we'll give you just a few more seconds, and then we'll take a look at the results. Kristine, I don't think you'll be surprised where we're seeing the majority of thoughts here. Okay, friends, let's do a countdown. 5, 4, 3, 2, 1. Good, I'm ending the poll. Let's take a look at the results. And there they are. You can see that the majority of you think engineering technology is the right place for IoT, but you'll like this, Kristine, followed very closely by CIS, right? So that's good. Nobody chose business here. That's okay. So thank you, friends, for giving us your sense there. Kristine, I'm going to stop sharing at this point and ask you to share your screen and begin your discussion today.
Okay, thank you, Mike. I'm going to share my screen. And while I'm doing that, I just want to encourage anyone if you have questions, just please feel free to ask them. I love interactive presentations, so we're all collectively together better, right? So I again, thank you for having me and this opportunity. This is something I'm very passionate about. Today, I'm just going to give you a quick overview of what IoT is, where it's used, some of the challenges we face when we're incorporating it into the curriculum, and then talk about some professional development opportunities that can help you learn more about it. And let me move forward with a slight warning, because beware of the rabbit hole. this is a huge topic and it's ever evolving, and more items get digitized and we become increasingly connected in sectors such as business, healthcare, manufacturing, but personally too. So it's important to remember that IoT is a broad term, and the technology continues to evolve. So we need to be careful, not be careful, but be careful of your time, because I've gone and I thought, okay, no problem. I went through one article and 4 hours later, where did my time go? I've been like delving into all these articles, but it's so interesting. But what is IoT? One of the definitions is it's a growing system of billions. I mean, a lot of devices that are connected around the world and through each other, through wireless networks, as a way to collect, share, and analyze information. It's helping us build smarter processes and more informed processes. So you can see some of the use cases in IoT. I don't want to focus on this because I want to talk about other things and how to incorporate it, but you can see manufacturing, transportation, retail and wholesale, our healthcare, government and city, smart cities. We all encounter these IoT technologies almost every day. I would say every day. This graph shows the growth of IoT from just 2015 to 2020. This was the spending for IoT devices across sectors and billions of dollars in 2015, just to show you the exponential growth. In 2020 alone, you can see in manufacturing, logistics, and transportation and other fields, look at it. I mean, it's like completely, the growth is huge. It's exponential. This is another illustration that further echoes the growth of connected things. And this is all demonstrating the need to try to get our workforce ready for technicians, IoT technicians, so that we can implement these devices. So you can see in by 2050, there'll be more than 1 billion devices connected. And you can see the spending too and the economic impact. But there's a problems because it's ever growing and ever evolving. I like to think of it, and I like the statement that IoT is like putting together a puzzle, a jigsaw puzzle without any edge pieces. It's constantly evolving. And who knows what's going to happen in the next 10 years? It's increasingly different. But here's the challenge. There's a skills gap, and we as educators and business leaders and anyone that can help your students, I help my students. We want to bridge that skills gap, and there's a lack of skills and understanding that's delaying the implementation of IoT and the big data and other technology trends that impact IoT. Microsoft, just to make the case too, Microsoft says there's a lack of talent and training that presents challenges for almost all of or half of IoT adopters. 47% of the companies that have adopted IoT say they don't have enough skilled workers to support it or available resources, and that only 33% of IoT adopters feel that they have adequate workforce to see the projects through realization. So there's the need that we need to educate our students. But then you're saying, okay, we see this need, but what's the challenge in integrating IoT into our curriculum? There's a lot. So because of the nature of IoT and the multidisciplinary nature of it, the titles and duties of the roles are not clearly defined. You might, there might be just one IoT technician out of hundreds of job postings, but you can see some of the skills IoT requires in other job titles. So the fact that the titles and the duties are not clearly defined makes it hard. Also, because of the IoT being a new field, there's very few academic programs available for students specifically on IoT. And so what we're proposing, and one thing that our college or the CASIA area, that what we call the Center for System Security and Information Assurance, or CASIA, received an NSF grant for IoT Coordination Network. But they're working on identifying the work roles. What are companies calling these jobs that need IoT? What's the lexicon being used for the jobs for troubleshooting and maintaining IoT systems? And what are some of the specific technical work roles for the IoT? And what are the competencies students will need? And then teasing out, well, what colleges and universities and four-year schools have program outcomes with major certificates and courses in IoT? So we're working on putting those reports together. So we got a little delayed with Corona, but Our network will have 2 published reports, one on workforce competencies, which identifies what companies are looking for from community colleges and what we need to teach our students and the necessary capabilities and competencies they need to related to IoT. And the second one is a report of all the different degree programs, certificate programs across the nation. There are not that many, so that's making it difficult. And at any point in time, anyone has questions, please let me know. But I proved I think I did a nice, not nice job, but I think I proved that there is a demand for skilled technicians and operators. But what kind of skill sets do they need? So under the IoT skill sets, our students need electronics, they need networking, they need programming, they need mechanical design and cybersecurity along with data analytics. So this is what makes it so difficult to place in-house IoT at a college. So it really needs a shared approach where people are collaborative and build partnerships across their curriculum, because it's not the diversity of all these skill sets would be hard to house in one department. And also there would be a lot of overlap. So it would be really good to have cross collaborations across the college. Again, it might be housed in electronics, like we did our poll earlier, manufacturing, engineering, CI. I like to see it in CIS, but we have it housed in our automation, engineering, technology area. But knowing that it may be housed in one area, but it's owned by a lot of different departments. So I just want to cover really quick what we're doing at Moraine Valley Community College in terms of our college curriculum. And I also want to talk about the IoT Educators Academy, which is a professional development opportunity for educators across the country to get involved, and some IoT educational resources if you're interested in learning more about IoT. So I have to credit my colleague, Chuck Bales. He and I work together. He is an mechanical engineer. I have a business background and a computer science background. So I just want to say, when we developed this course, we had like students like myself in mind. So we didn't want any prerequisites. And we wanted to break down the silos of the various disciplines and bridge them, because IoT is a convergence of a lot of technologies. It's multidisciplinary in nature. So when I was thinking about it, looking at some of the other IoT curriculum, and my colleague, I'll have to, again, Chuck Bales is an excellent colleague to have. But we thought, well, we don't want prerequisites. They can be a barrier. We want to remove barriers for our students so they can learn about this very timely topic without having to go through a number of prerequisite courses. And thinking of myself, when I was looking at courses, you needed to have electronics, engineering, programming before you could even hit something that I was really interested in. So thinking about that, we wanted students to get excited about this topic, and then they could delve further in to the different disciplines under the IoT skill set if they should want to. So we wanted students that were interested in programming, electronics, digital electronics, and then learn more about them, because we don't have prerequisites. This is a course that's multidisciplinary. They get a lot of electronics, a lot of programming, a lot of logic, and again, we wanted no prerequisites so that students would be exposed to all of these skills. And then they might not even realize that they liked programming and they were more electronics based. And they said, wait a minute, I can see some of these things really helping me in my electronics. Or programmers saying like, oh, I wanted to do this project, but I didn't know how to approach the electronic portion of it. So one thing too is that we made sure that students had a hands-on project-based learning experience, which they really love to do. They build things, those things function and perform as they should. So it's not just theoretical. Again, this class focuses on embedded systems, and it also maps to a credential our students will take, potentially if they pass, it maps to the Arduino fundamental certification or certificate. So that serves as their final project. And I'll talk more about that, but it's a $30 certificate or voucher. And it also comes bundled with the physical kit that we ask students to get. And then I'll talk more about this, but this whole class is primary based on getting students interested in these topics so that they can go back and branch out into different areas that they like and get strengths in those areas, but they understand how all the core components fit together. And our future courses are going to focus on IoT connectivity and data analytics. This is the certification exam. The exam is only $30. We have our students purchase a bundled kit that has all the physical components and elements they need to build projects based on the book. It's a roughly $120. And it includes a certification voucher. But if you want, as an educator, to just have the voucher and then you teach them and have them go through some of the projects, they can. It's $30. So it's a very inexpensive, very economical for our students, and it's an industry recognized credential. And I should mention is that everything that you can do in these Arduino books can go into Tinkercad, which is a free GUI-based, cloud-based solution that allows you to build circuits and program them. This certification exam tests students on their knowledge of electricity, programming syntax, electronic components, the IDE used to program, frequency and duty cycles, schematics and circuitry, programming logics, and the various Arduino boards. So they get a really well-rounded survey course that, they could say, I'm not so great. I don't like understanding pulse width modulation, but I really like the programming of it. So those are some things that we can, that I enjoy. And our students have really come back and really thanked us and said, thank you. I would have never thought to go into this area. And they're even more pleased when their final exam produces a certification and a credential that they can post on their LinkedIn. They get very excited about it, which I get excited about. I'm like, oh my gosh, this is awesome. It really makes me happy when they pass. And, I should tell you, it's not an easy exam. It's pretty challenging. And, but our students do fairly well with it. One thing, I serve as director of faculty development at my college. So one thing I really have a passion for too is to help other faculty. And so if you're asking yourself, how can I get started with incorporating IoT into my classroom? How can we get a program or certificate started or a degree? There are tons of opportunities to help you get started. And just don't feel overwhelmed. That's the one thing I kept telling myself. You can start slowly by introducing IoT by using a lesson or a unit and then a class, and then you can build on it. So I say start small if you're apprehensive. Just incorporating something like, even in whatever discipline, it could be business. What is IoT? And then maybe even turn to Tinkercad, because that threshold is very inexpensive. All you need is a web browser, and your students get free access through AutoCAD for Tinkercad. It's an excellent tool. And then you can have students start building some of the circuits. What's the difference between a series and parallel circuit? And then they start thinking, wait a minute, I can see some of the logic that translates over to how we program sometimes. So that's something I just didn't want to, I wanted to mention. So our IoT Educators Academy is all centered about how can we help teach the teachers? How can we get this information out? How can we train high schools and the colleges and universities? So, and especially how can we get people to feel confident and gain the skills necessary to teach this course? So that was really important. So we put together, we call it the IoT Educators Academy, and we have a 2-tier, one on basic electronics for IoT and the other one for IoT fundamentals. We're merging them this summer because some people have commented like, oh my gosh, I didn't have an electronics background, which made IoT fundamentals a little more challenging. So we wanted to say, okay, we're going to give you that the electronics background, or those people who like, I haven't seen some of these equations for 20 years. So we wanted to kind of give them a refresher. But then we have 2 upcoming classes I'll mention in just a minute, but a couple of benefits of this is that you as a faculty member, if you go through the academy, experience the curriculum as a student, and then you can discover potential pain points that your students might have. And you can say, okay, I've done this, and wait a minute, here are the questions I can anticipate my students having, and then you can start building in some more curriculum for that. You could build, this IoT Educators Academy also builds a network of educators that share resources. We've had people that like build friendships. And so like when someone sees something online, they'll send it to us and be like, can you share this? And we've built really nice relationships with everyone who has taken this class. And some faculty, after they take this class, take the certification exam and they pass and they email us. They're like, I got my cert. So that to me is like super exciting. So, and this is just one way for you to break the ice. Well, like, what's the worst that could happen? You learn something, as you have a little Tinkercad, you get a little bit of what IoT is. So when you see like, wow, where are the parking spots? And I live in Chicago, you can go on your app and find out empty parking spots. Could that be IoT? Maybe. So you can appreciate where you see it in your life. So we have 2 classes coming up. One's May 31st to June 3rd, and the other one is August 1st to August 4th. And let me I can, it's on the Cassia website.
While
So
you're doing it, Kristine, are these face-to-face?
these are currently still virtual, so it makes it easy to attend.
Okay, thank you.
So let me throw this in the chat. But if you go to training and events, you'll see our 2 classes. And we make this, and I joke with my colleague Chuck Bales. I'm like, it's IoT fundamentals, because we like to have fun, because if you're not having fun, you're not going to learn. So that's important to us. So just so you're aware, another resource that we have is the IoT workbook. So, I should also say, all the resources that we have in this class are given to you freely through a free Canvas shell. We want you to use it. That removes a barrier for faculty, because sometimes we don't have time to develop our own materials. You can take what we have and elaborate on it or modify it, whatever you'd like. One thing we did too is do the IoT workbook that exposes students to real world program or problems and solutions. So Chuck and I wrote this book using Tinkercad, using a scaffolded approach. So we use embedded systems, and the students get to know what sensors are and what actuators are and what the programming is. And Tinkercad makes the exercises more accessible. Again, that barrier, the cost barrier is not there. It's free. So all you need is a web browser. So it's one way to kind of showcase where IoT can create efficiencies in the manufacturing. It's a multidisciplinary workbook. And what we did was have a scaffolding approach. So we introduced, for each of these problems, we introduced components, like your electric components, like what are sensors and what are actuators, discuss the circuitry of it, like here's a schematic, where are the connections, why are they there? Discuss the programming logic, the format, the syntax, the debugging, which is the number one thing people learn the most about when it doesn't work and you troubleshoot. We want to give students those troubleshooting skills. And then we test and discuss the IoT application. So we definitely wanted to make sure students had a really good foundation when they started, and then they get more complicated as the scaffolding increases. For faculty wanting to learn more, or for students, you can always go to Python or C++.com. They have Blockly, Linux, like having all of these skill sets helps. And also, there are development kits that you can get. SparkFun, this is the Arduino kit that we have noticed. They have a little multimeter and all sorts of different kits that you can get low cost. One thing I really like is that SparkFun allows faculty to create your own kits. So you can work with your own, if say, for instance, you have a number of a number of problems or something that you want to, or projects you want your students to work on, but you don't want them to get this huge kit that has things that you're not going to use. You can really create your custom kit, which is super cool. And one thing that's neat too is that SparkFun has a free course curriculum. So again, you can take these things that are already built, and that's that barrier to entry for your courses. If you just wanted one thing, you could do that. For the Pi Academy, you could, that's another one for Raspberry Pi that you can check out. That's a really neat tool. Sometimes they have, pre-COVID, I believe they had workshops that you could go and attend physically. Cisco has IoT curriculum for online instructor training. The first one you see here, which is the Introduction to IoT, is free. But if your college is a network academy, you can get into these courses too, or one. They're fantastic. You can also take IoT courses from edX and Coursera. They're just the introduction. And again, you need to, what's the focus? If you're heavily like electronics focused or engineering focused or business focused, you just need to be aware of where your focus is. One thing that Microsoft launched last year was IoT for Beginners. It's curriculum offered through Microsoft, and they have a GitHub page where you can go through the curriculum. There's 12 weeks of worth of work with 24 lessons geared towards college. They've been vetted through college students themselves. So they I think they're Microsoft Learn ambassadors, student ambassadors work through it. And I've been talking about Tinkercad a lot, but this is what Tinkercad is. It's a gallery. They have lessons and projects and artifacts that you can use. People have a ton of different resources out there, but you can see we have our Arduino board and a breadboard, the wiring, the LEDs, resistors. So students can build it and they don't have the cost associated with getting all of these components. Now, typically, I mean, it saves them money, but what's really cool too is that they can build a project in Tinkercad and then develop a list of things that they need to buy and then buy them to see if how they function. So a lot of times you're like, oh, I'm going to buy all these things, and then you end up not using them, or they don't have they have compatibility issues, or something happens inevitably. And then there are a ton of IoT project banks, tons of them, and they're high quality. Arduino actually has a really cool site where, every week they have like a webinar or they have a podcast, and they have fun projects that you can do. And they're high quality. The Pick Academy is what the Raspberry Pi, Spark Fun, Adafruit, they all have wonderful resources we can use as educators. So the entry point for us isn't so bad. I promised I wouldn't talk too long. So I'm going to close it out and say thank you for your time and this opportunity. I'm very excited about this topic. I should also thank, and I want to credit my colleague Chuck Bales, who has been awesome with me. He's taken me under his wing because, again, I have a business and computer science background, not an electronics background, and he really helped me out. And one thing I would suggest for colleges too, and it's worked very well for us, is that you cross collaborate with people in different disciplines. That's where you can really benefit and gain efficiencies. Where I'm strong, I can help, and where Chuck's strong, he's helped. So it's been a wonderful partnership.
Thank you, Kristine. So how did it work with Chuck? Did you just call him up one day and say, hey, we should do something together? Or how did it work?
I called Chuck because I said I was super interested in it. And I thought, well, how do I get started? So poor Chuck, I called him. He came back.
Did you know him? Did you know him?
I did. I served on our curriculum review team, and he was introducing a new course in robotics. And I thought, okay. And on the way back, we both teach in the same building. And I asked him, I said, well, how do I get started in teaching this? Because I'm very interested. And he said, well, call John Sands, which I did, and the rest is history. But Chuck has been my colleague that's been completely supportive of me. And had it not been for him, it would have been, he helped spark my interest, and he's helped me when I had difficulties. But and I hope I helped him too. But I think collectively we have a better program because of our viewpoints and diversity of our viewpoints too.
I think you've made a great case today of working across disciplines, right? Or where you're bringing something to it, and that idea of no prereqs, right? That really strikes me as lowering that barrier, right?
That was paramount. That was we've had students from all sorts of disciplines, and they just to see them. And one thing too, Mike, is that we have them record their projects, and they talk us through what they did. Yeah. And the really cool thing is you can see them talking to their family members. And what's really even more inspiring is that they're talking to their siblings, their younger siblings, and the siblings touching their circuit and helping them press buttons. And it just inspires a lot of learning and excitement.
I bet you it does. Those courses that are coming up in the summer, you mentioned they're virtual. Is there a cost associated with those?
No, they're free. So if there's space limited, but they're free, and we'd love to see people in them.
I know we just have a short time, but I've got one more question, and then we'll wrap up for today. How much there's data in there? Do they do anything with the data at this point, or they just get it?
They just get it. So we're still building our program, but that's our next step. Is the curriculum development process takes a while at each college. So and COVID kind of hurt, but no, that's our next step, is to take the data, and partner with our potentially our math department or another department and work on that. We're building a Python class in my department, so we're hoping that we can further collaborate.
All right. Well, listen, Kristine, I'm just excited to talking to you. I'm enthused about doing this myself every time I talk to you. Let's go ahead and take a look at our slides for today. Participants, join me in thanking Kristine for that just amazing view of how she did and how it worked. I want to point you again to our website, preparingtechnicians.org. You'll get that PDF sharing a framework for cross-disciplinary STEM. There's instructional cards. Kristine, I bet you're interested in those as a faculty professional development opportunity, those instructional cards. There's the podcast. Kristine was featured on a podcast a couple of episodes back. That was fun, Kristine. And I invite you to share the recording of these 3 short 30-minute webinars that talk about the preparing technicians for the future of work. Here's some of the cards, right? And there's one on Internet of Things as well in the center there. I'll point you to the website, preparingtechnicians.org. The podcasts include everything from number 38 you see there to technicians in the new blue economy, the ocean economy. And there's Kristine's episode 37, Incorporating the Internet of Things. Kristine, that was a lot of fun working with you on that one. There's more resources associated with the podcast. And finally, this is number 3 in the webinar series, Integrating Emerging Technologies. If you haven't had a chance to attend or to review the first 2, find the URL on our website and take it from there. Colleagues, thank you very much. As you exit today, a survey will pop up. Take a few moments just to complete that. Kristine, thank you again. Just lovely talking to you.
I thank you, Mike. Thank you for the opportunity. I really appreciate it.
Goodbye, everyone. Happy Friday. Thanks for joining today.